I will explain the explanation of the given sorts which I have shown over here. Okay, so what are the steps which we have covered? I will show you. Even I will show how to solve this question. Okay, so what is the question which is given? Here in this question we have been given a cuboid. This is a cuboid, right? And for the given cuboid we need to find the volume. Okay, so let's say I'm just drawing it separately. Yes, so I'm keeping it aside and solving it in a fresh page, right? So if this is a cuboid which I'm drawing it over here, let's say what are the different dimensions of a cuboid, you know, students? If this is a cuboid whose one of the face looks like a rectangle and this is connected like this, these are the heights of the cuboid. So here the different dimensions which I have mentioned is L, B and H, where let's say this is L. If this is length and you know this is height, let's say this is height, right? And this is the breadth. This one is breadth. I'm marking it with B, right? It's given that area of the adjacent faces. What are the adjacent faces? Which are near and stick to each other. If this is one of the adjacent face, let's say this one, this rectangle, this is formed by which two sides? This is formed by, this is breadth, so this is also breadth. If this is breadth and this is height and the side opposite to it, that is B into H, right? So the dimension of this shaded side is also B into H. Changing the pen, B into H, right? And adjacent to this is this side having the dimensions L into H. So this side is having dimension L into H, right? And what is the third side? That is this height and this breadth. This height and this breadth we have already taken. We have taken L into H, and L into B is the third side which is adjacent to it. That is the, you can see the bottom portion, this one. I am just marking it here. This is L into B. So it's given that area of adjacent faces, what's that? 15, 20 and 12 centimeter square. These are the area of the adjacent faces, and you can see the three adjacent faces are having the area L into H, L into B and B into H. Are you able to understand it? These are stick to each other. That's why it's say adjacent for this cuboid, right? Now, if the area of the adjacent faces are 15, 20 and 12, then can't we say that L into B, maybe let's say if L into B is, let's say 15, L into H is, let's say 20 and B into H is, let's say 12, because whatever be the values, these are the three adjacent faces and these are the three values which may settle with any of these three that is L into H, L into B and B into H, and just multiply the LHS and RHS together, this one and this one, because we need to calculate the value. So for this just multiply it. When you multiply the LHS, it will be L into B into L into H into B into H. That will be equal to 15 into 20 into 12, isn't it? This is LHS and this is RHS. Right now you can see L is coming two times, B is coming two times and H is coming two times. So can't we write it as L square B square H square is equal to 15 into 20, it will be 300 into 12, right? And the next step to this is L B H whole square, because L square B square H square is LBH whole square. It can be written like this, and into the RHS it will be 12 3 36 3600. Take a square root in both sides of the equation. We get LBH equal to 60, right? So what is LBH? LBH is the volume of this cuboid. Yes, we have solved this question now. Cuboid volume. This is the cuboid volume, LBH 68 centimeter cube, because L the centimeter of this, centimeter of this, centimeter of this. This will be multiplied together to get the value of 60 centimeter cube, right? So students, hope you are able to solve this question. I have just dropped the sorts of this question, and just to give the explanation I am coming live, so that any queries which you guys have, I can handle those queries, right? So in this question a cuboid was given. It was a cuboid. It was a cuboid. Area of the three adjacent faces are given as 15, 20 and 12. We need to find the volume of this cuboid. That what is the volume? We know the volume of the cuboid. What is the formula of the volume? That is L into B into H. We know it, right? So what we did, we know the three adjacent faces are stick to each other, right? These are stick to each other, and these are the three faces having the dimensions L into H, L into B, B into H, right? So what we did, we just kept the value of this the data as given in 12. We have just kept the value L into B, L into H 20, B into H 12. Don't worry that what will be coming, 15 will be for L into H or L into B or B into H, or 20 will be for whom. So just put up this value for any of these L into B, L into H or B into H, right? And just multiply the LHS and RHS to get L square, B square, H square equal to 300 into 12. Why 300 into 12? Because of all these figures into the RHS will be multiplied. Now we are having L square, B square, H square equal to 300 into 12. That means LBH whole square is coming at 3600. Now we can write it like this, and we know that LBH is the volume of the given cuboid or any cuboid, and we have taken root, square root of both sides of the equation to get LBH as 60 centimeter cube, right? So this is the volume of the cuboid which we have derived when it's given, the data given into the question is the area of the three adjacent faces is this one, right? So students, I want to interact whether it is just understandable to you or still some query. Yeah, you are most welcome to put your doubts into the question, into the chat. Yeah, this is the source which I have put into my channel, and I am just explaining those sorts and trying to come in a day or alternate day every day, right? So in this way we have solved this question. You can see I have just put up the source of the same question yesterday. This is right. So now coming to the explanation of the next sorts. Okay. So I hope this is clear to you. When cuboid is given, the area of the three adjacent faces is given. We know that the three adjacent faces are stick to each other and these three adjacent faces will be covering the area of L into H, L into B, and B into H. So just writing the value over here again and putting the value, multiplying the LHS and RHS to get L into B, L into H, B into H equal to 15 into 20 into 12. Now taking a square root of the LHS and RHS, we get the value of the volume of the given cuboid, right? Now coming on to the next question, which I have put the medians. Okay. So I will just solve this question here again so that we will be able to understand what we are the source which I just put up on my channel is that the sum of the two sides of a triangle is greater than 2 times the median. If AD is the median, sum of the two sides of the triangle is greater than it, right? And another question which is deriving from it, the sum of all the three sides of the triangle is greater than sum of its three medians. Okay, so we are going to solve it. Okay, just give me 1 minute. I'm just changing the page. So this is a triangle given. This is a triangle given, right? This is a triangle given. Let's say A, B, C. Do the nomenclature. Now, if AD is the median, AD is the median. Let's say this is the point where median meets. Then this is AD. Let's say AD is the median. Then what we do? Just if this is AD equal to this, just extend it so that AD equal to DE. If this is E, I am changing the pen multiple times so that it will be clearly visible. And now connect E to C. What we are going to prove that AB plus AC is greater than 2 times AD. This is the proof which we are going to do. This is number 1, and number 2, AB plus AC plus CA is greater than AD, and let's say the three medians, whatever it be, if one is AD, another is, let's say, BP, and let's say the third one is CQ, then AB plus AC plus CA is greater than AD plus BP plus CQ. Just mark it AD, BP, CQ as median. So I am writing AB, BC, CA are the sides of triangle, right? AB, BC, CA are sides of triangle, and AD is the median of ABC. Similarly, BP is the median of ABC triangle, and CQ is also the median of ABC triangle. Why I am just writing it with this line? Do you know, students? Because AD is dividing BC equally. This is the property of median. Okay, a median divides this side, opposite side, equally. And just naming it AD, BP, AD is this one, BP is this one, and CQ is this one. AD, BP, and CQ. These are medians. These are medians. Right? Now, what we did? We did a construction, extend AD to till E. Now, with this construction, just consider these two triangles. Which one? Triangle CDE and BDA. Here, this is the vertically opposite angle. This one, isn't it? Tell me. These are two lines and this is the vertically opposite angle. This one. I'm just keeping it closer so that you will be able to understand. This is the vertically opposite angle and AD equal to ED. See it. AD equal to ED. This is one of the side which is equal. So I am mentioning AD equal to ED. This is 1S and this angle is equal to this angle, vertically opposite angle. So let's say if this is angle 1 and this is angle 2, then we can say angle 1 equal to angle 2. So this is A, right? What I want to prove, by side angle side, these two triangles are congruent. How? One is AD equal to DE or ED, which way I put, this is one of the S. Angle 1 equal to angle 2, vertically opposite angle. This is angle 1 and this is angle 2, marked in red here. And one side is equal, one angle is equal, and this is the third side, BD equal to CD. Because AD is the median, it divides BC equally. That's why BD equal to CD. So just I am writing over here BD equal to CD. So this is our third side, isn't it? This is our third side. So by side angle side, these two triangles are congruent, isn't it? By side angle side, can't we say that triangle ADB is congruent to triangle CDE, right? ADB is congruent to CDE. This one, same I have mentioned over here. So if these two triangles are congruent, then what will happen? We will say that since the congruent part, common part of the congruent triangles are equal, or the congruent part by CPCT, we say that this side is equal to this side, right? So we will be writing it as AB will be equal to EC. Just mark it in writing the nomenclature. AB is equal to EC because A is here, okay, and B is here. This is the third side of this triangle, and EC will be equal. Why equal? Because we have proved ADB is congruent to triangle CDE by side angle side, right? So if AB is equal to EC, right, just add these two sides, AB plus AC, AB plus AC. Consider this triangle ACE, the bigger one, this one. So I am writing in triangle ACE. What will happen in triangle ACE? We will write AC plus EC is greater than AE. Why? Because the sum of two sides is always greater than the third side of the triangle. So I am considering this triangle, this one. So this is triangle ACE. So in triangle ACE, just writing AC plus EC is greater than AE, isn't it? And what is AE? AE is AD plus DE, and AD and DE are equal. We did this construction. Since AE is can be written as AD plus DE, and since AD equal to DE, therefore we can write AC plus EC is greater than AD plus, in place of DE, write AD plus AD. So you can see AC plus EC, and since EC is equal to AB here, by CPCT and proving the congruency of this triangle, we can write, since EC equal to AB, we can write in place of EC AB. AC plus AB is greater than AD plus AD, that means 2 times AD, or just change the sequence to get AB plus AC is greater than 2 times AD. So we have proved the sum of two sides of this triangle is greater than the 2 times the median. So the first part of this question is solved. AB plus AC is greater than 2 times AD. This is proved, right? Coming on to the second part. Students, if AB plus AC is greater than 2 times AD, if AB plus AC is greater than 2 times AD, I am drawing this figure again so that it's very easy to understand, right? Because this is seems to be some complicated, so don't get confused. Yeah. If I am drawing this figure again just to explain the medians only, because this is little haphazard, right? So here what we proved, if this is the median AD, then AB plus AC is greater than 2 times AD, right? So if BP is the second median, is greater than 2 times BP, right? So I'm writing the same figure over here. AB plus BC is greater than 2 times BP. Why? In the same fashion, we can prove it. As we proved, AB plus AC is greater than 2 times AD. Right? Now, what will be the third median? This is CQ. This is coming like this. CQ. Similarly, AC plus BC is greater than 2 times CQ. So we will write it. AC plus BC is greater than 2 times CQ. So just see AD, BP, CQ. AD, BP, CQ. These are the medians. So into the RHS we have the medians. So just add these equations, these three equations. This one, which I have kept into bracket. You can see AB is coming 2 times, AC is coming 2 times, and BC is coming 2 times. So just on adding LHS and RHS, can't we say that LHS is 2 times AB plus BC plus CA, right? If LHS is 2 times AB plus BC plus CA, what will be the RHS? Into the RHS we have AD, BP, CQ, and AD, BP, CQ are the three medians. You can see this figure. I am just explaining this figure again so that you will be able to understand. So into the RHS, this will be the LHS, and into the RHS you will be coming, a greater than sign is coming in this inequality, and into the RHS we are having 2 times AD plus BP plus CQ. The same thing over here. Just cancel out this 2 and 2, and you can see AB plus BC, AB plus AC, AB plus, this will be BC, AB plus BC plus CA is greater than 2 times, is greater than all the sum of 3 medians, sum of all the 3 medians. So AB plus BC plus CA is greater than AD plus BP plus CQ, which are the three medians. So here we have proved that the sum of the three sides of the triangle is always greater than the sum of the three medians, right? We have proved the sum of the three sides is always greater than the sum of the three medians. So we have proved this one also. The second part is also proved, right? So students, I tried to explain the concept lying behind the shorts which I put into my channel in last 2 days, and I have explained those things to you. If anything is coming to you, just you can drop a message to me. Okay, I will try to help you, and just don't leave it. Hold it tight and do your hard work. You will get the success, and whatever the support required from my side, I will always there to help you. Okay, and keep on learning, do hard work. Success will definitely, you will achieve the success, right? Thank you for watching, and keep on learning, dear students. For any specific area or any specific topic, you can drop me, I will help you. Okay, so here we have taken three questions today into this short explanation. The first question is that I have taken a cuboid. The three adjacent faces area is given. We need to calculate the volume of this cuboid. What is the volume? So for this, what we did, we just solved in the same fashion: L into B, B into H, L into H. Okay, this one, L into B, B into H, L into H. Just multiply the LHS and RHS to get LBH whole square equal to 3600 into the RHS. Take a square root and we get the volume of the cuboid. The second question which we solve today, that a triangle is given ABC. We need to prove the sum of two. We need to prove here that AB plus AC is greater than 2 times its median, right? Where AB, BC, CA are the three sides of the triangle, and AD, BP, CQ are the three medians of the given triangle, right? Now what we did, we just extend AD to DE, right? After that, we proved congruency of triangle ADB and CDE by side angle side, right? After proving this congruency by CPCT, we said AB equal to EC. Here you can see AB equal to EC. By CPCT we proved we just taken this AB equal to EC. Now considering this shaded triangle ACE, in triangle ACE, what we did, in triangle ACE, AC plus EC is greater than AE, because sum of the two sides of a triangle is always greater than the third side. एक ट्रायंगल के दो साइड्स जो होते हैं, उनके दोनों साइड्स का जो सम थर्ड साइड से हमेशा ज़्यादा होता है, चाहे वो किसी भी तरह का ट्रायंगल हो, एक्यूट हो, ऑब्ट्यूस हो, स्केलन हो, वाट एवर, राइट एंगल ट्रायंगल हो, कुछ भी हो. So the two sides of the triangle, when we take the sum of the two sides of a triangle, it is always greater than the third side. So AC plus EC is greater than AE, and we know that AE is AD plus DE. Why? Because we did this construction, extended D to E. So since AD equal to DE, into the RHS we can write AD plus AD. So sum of the two sides of this shaded triangle AC plus EC can be written as greater than 2 times AD. But EC is equal to AB. Here we have by CPCT and by congruency, proving the congruency of these two triangles, we proved AB equal to EC. So that's why in place of EC we have placed this AB here, right? We have placed this AB. And after that we can say, changing the sequence, AC plus AB or AB plus AC are same thing. So AB plus AC is greater than 2 times the median, right? Similarly, just drawn the figure again with a clear visibility. And here if AD, BP and CQ are the three medians as mentioned over here, we can similarly we can prove, as we have proved AB plus AC greater than 2 times AD, we can prove AB plus ABC is greater than 2 times BP. Similarly AC plus BC greater than 2 times CQ. Now add the LHS and RHS of this inequality. Then we get AB, you can see coming 2 times, BC coming 2 times, AC coming 2 times. So 2 times AB plus BC plus CA is greater than 2 times the sum of the medians. 2 will be cancelled out, and we have proved the sum of the three sides of the triangle is greater than the sum of its three medians. I hope you like the channel. Keep on learning and happy learning. Bye bye.